Hey guys, today we're going to talk about divisibility rules. So with divisibility rules, you would use divisibility rules when you're talking about division, when you're talking about fractions, when you're talking about factors. So by the end of this, you're going to be able to tell me if 821 is divisible by 3. And it is, but the question is, will it have a remainder or not? Is 8,120 evenly divisible by 5? 8,164, if that's evenly divisible by 2. You're going to be able to do this and know this by the end of the lesson. So you're able to know if I'm setting myself up for success, I know that I'm looking at this thinking, okay, am I going to have a remainder at the end? Okay, that's your big question too when you're thinking about that. Okay, you also can use it when you're looking at fractions. Am I able to reduce this fraction using divisibility rules? So lots of these different things are going to use divisibility rules, okay? So you're going to need a handout. Your handout looks like this, okay? We're going to go through, we're going to write our rules and examples, rules and examples, rules and examples. And then once we're done, then you're going to get a paper and then you're going to go ahead and try to see if you can tell and identify all of the numbers that each are divisible by, okay? So let's look at the number 2. 2 is the easiest one, okay? 2 is the last digit is an even number. Well, what's even? What number is even? Well, I know that the number 2, I know that the number 0 is not even, but that's still, you can evenly divide a number, anything ending in a 0. So 0, 2, 4, 6, or an 8. So any number that ends in a 2, 4, 6, or 8, it is evenly divisible by, or it is divisible by 2. So for example, the number 128. Okay, what did I just say? The last digit is even. Okay, looking at the last digit. That is even, so therefore, yes, it is divisible by 2. Looking at the number, you can look at a number like this, 53,132. Last digit is even. Is it even? Absolutely. Therefore, yes. Okay. We have the number 319. Last digit, there's no 9, so therefore no. So, and when you're talking division, that would mean if I were to divide 319 divided by 2, because it's not evenly divisible, that means I would get a remainder. Okay? So, exactly what it says, the last digit is even. If it doesn't matter if it's a 2-digit number, a 3-digit number, a 2-digit number, a 5-digit number, a 97-digit number, looking at your last digit, is the number even? If it is, then it's divisible by 2. When a number is divisible by 3, we've talked about this once before, but now we're going to get it on paper and write it down. I told you that we would revisit this. We are. So, the sum is an addition problem, the answer to an addition problem. The sum of the digits is divisible by 3. Okay, these are my things. Sum is divisible by 3. So now you're asking for examples. Okay, the number 57. 57. Well, I'm going to come over here. My digits are 5 plus 7. What is 5 plus 7? Okay, it's 12. Is 12 evenly, or can I divide 12 divided by 3? Absolutely I can. So therefore, yes. That means 57 is evenly divisible by 3. So that means if I were to do 57 divided by 3, I would have no remainders. Okay? Next number, 41. The number 4 plus 1 is 5. Can I divide, in real world, 5 divided by 3? Is it divisible by 3? No, it's not. So therefore, no. Take a 3-digit number. It doesn't matter. Take a 3-digit number. Okay? 3 plus 1 plus 7 are my sums of my digits. 3 plus 1, or excuse me, 7 plus 3 is 10, plus 1 is 11. Can I divide 11 divided by 3? No. So that means, again, if I were to divide 317 divided by 3, I would have a remainder because it's not divisible. Okay, next one, number 5. You know this one. See if you can think about it before I write it. So if the number ends in a 0 or a 5, that must mean it's evenly divisible by 5. So for example, 60. Does it end in a 0 or 5? Yes, it does. Okay. Do I end in a 0 or 5? Therefore, it is not. Even though it has all 5s in there, doesn't matter. And 5s and 0s. Nope. But this one does because it ends in a 5. Once again, don't forget to press pause. Okay? If you need to catch up. All right, the number 6. This one's a tricky one. This combines 2 rules. Okay? So this is combining 2 rules. All right. So if number 6, if my number is divisible (2 and 3). Okay, so that means it has to go with the 2 rule and the 3 rule. Okay, so let's look at a number. Number 81. So that means it has to have the 2 rule and the 3 rule. All right, well, what's the 2 rule? Okay, so the 2 rule, the last digit is even. Is my last digit even? No. Okay, let's just, for all intents and purposes, let's practice our 3 rule. Our 3 rule is the sum of the digits is divisible by 3. So that must mean I'm going to take 8. 8 plus 1 is 9. Is 9 divisible by 3? Can I divide 9 divided by 3 in real life? Normal? Absolutely. The problem is you need to have 2 checks. So this means this is not divisible by 6. Another example, let's do 96. Okay, 96, my 2 rule. My 2 rule is the last digit is even. Is my 96 even because it ends in a 6? Absolutely. Now my 3 rule is if the sum of the digits is divisible by 3. Well, let's take my digits. 9 plus 6 is 15. Can I evenly divide 15 divided by 3? Yeah, that gives me 5. Okay, great. So ladies and gentlemen, that means 96. If I were to do a division problem, 96 is evenly divisible by 6. I know that it doesn't look like it is, but if you were to divide it, it absolutely is going to be. Okay, so then let's take a 3-digit number. Okay, so is my number evenly divisible by 2 because the last digit is even? Is my last digit even? No. So at that point, if it doesn't do for 2, it doesn't matter. It has to be and. It absolutely has to be and. So we can just stop and say no. Okay, let's do another 3-digit number. Okay, it has to be divisible by 2 and 3. Okay, my 2 rule. What is my 2 rule? You're right, it has to be even. Does my number end in an even number? Yes, it does. 3 rule. The sum of the digits is divisible by 3. Okay, 5 plus 0 plus 4 is 9. Is 9 divisible by 3 in normal? 9 divided by 3? It's 3. Doesn't matter what the answer is. I just have to know if this number is evenly divisible by 3, and it is. So believe it or not, yes. So 504 and 96 are both evenly divisible by 6. Okay? All right, the 9 rule is exactly like the 3 rule. Exactly like the 3 rule, but instead of it's divisible by 3, it's going to be divisible by 9. So when the sum of the digits is divisible by 9. Okay, now my examples. I'm just kind of writing blue and purple everywhere. All right, so 288. Okay, well then I have to come over here and say 2 plus 8 plus 8. What's 2 plus 8? 10. What's 10 plus 8? 18. Is 18 divided by 9? Can I do 18 divided by 9? Yes, I can. And what sounds so funny is I'm going to write up here, but this sounds so funny is that it truly is. Okay? So you put it in there, and you go in there, and it's 20, let's see, it's 22 times, believe it or not. 9 times 22 is 288. Okay? So it is. It's crazy. You don't have any remainders. So if you use these rules, it's going to help you. Okay, here's another example. 2,519. So I'm going to add my sums up, or excuse me, my digits up. 2 plus 5 is 7. Plus 1 is 8. Plus 9 is 17. Can I divide 17 by 9? That would be no. Okay, again, we're going to practice these. I just want you to get this. It's hole punched on your copy, and therefore it's going to stay in your binder at all times. You're going to use this so very much. All right, and finally, probably the easiest one, you guys, other than probably the even, 10 may be easier than that. If the number ends in a 0, therefore it is divisible by 10. And I should say 10, it should be 0. So, all right, 40, yes. 37, no. Why? 0, yes. 0, no. Simple as that. All right, now what you're going to do, let's look at it real quickly. Let's go back and look at my original problems. So if I were to look at this, looking at my divisibility rules, okay, I were to take this. So what's 8 plus 2 plus 1? 8 plus 2 is 10, plus 1 is 11. Is in real life 11 divisible by 3? So this is not. So you will have a remainder so that you can say 821 is not divisible by 3. Okay, my 5 rule. What is my 5 rule? Has it in a 0 or a 5? This one is in a 0. So is 8,120 evenly divisible by 5? Yes, it is. 8,164. My 2 rule is ends in a 4, which is an even number, so therefore, yes, it is. So that means if I would have done this, there would have been no remainders, and yes, there would have been a remainder because this is not divisible. And we'll talk about fractions in the coming weeks, but you would divide those by the common factor that they have. Okay? So again, going back and looking at this, please make sure this is done. This needs to be kept. You have 3 rings. Okay? Go ahead and you're going to have a worksheet practice, so please go ahead and get that from the teacher table, or unless I've already passed it out. Okay guys, on this paper right here, this is your practice. And it says, is the number on the left, which are these right here, divisible by the numbers on the top, the 2, 3, 5, 6, 7, 8, 9, 10? If so, place a check indicating so. The first one was done for you. So what I did right here is, is 36 evenly divisible by 2? Yes, because it is an even number. 3, 3 plus 6, because again it's adding. 3 plus 6 is 9, and I know that 9 is divisible by 3, so that's why. My 5 rule, Go look at your notes. What is your 5? Ends in a 0 or 5, so therefore it's a no. My 6 is simply if it is a yes and a yes, it is a yes here. My 9 rule is you add it together. 3 plus 6 is 9. Is 9 divisible by 9? Yes, it is. Therefore, it has a check. My 10 rule. It's not divisible by 10 because it doesn't end in a 0. So that means my number is evenly divisible by 2, 3, 6, and 9. And you do that for all of the other ones. Looking at your notes, taking your time. When you are done, you're going to keep it because we're going to go over it today, if not work on it today. Also, if you go on the Padlet, next to it is a divisibility song. So please make sure once you're done with this, you can look and watch the divisibility song to help you with your divisibility rules.